Hello, welcome. Thank you. It's nice to be here. This is my hometown. I just took my bike and came over here to Krasnopolsk in 10 minutes, so it's different from people with jet lags, etc., etc. So I'd like to invite you all to our house to have a dinner there, but we can't have that. So I want to talk about another problem. I'm a science writer and a type designer, and as a science writer I noticed that it's very difficult to get science into your presentations, into your text, into your the notes you give out to people. So it's very difficult just to get the easiest formula out. So what I want to do is to show you my problem. The problem we have with science writing, the solution we had invented with ATypI, and a bit about the implementation and show you how we did this, and of course the new problems. You know, you solve one problem, you get a new problem, but it's just on a higher level. Okay, so it's easy to do this sum. It's just, you know, simple arithmetic. Simple sums are okay to do if you want to add. You have a plus sign. But where do we get our multiplications in sign? Where on the keyboard is the multiply? Or the minus? It's very difficult to even get a proper minus if you're writing science. The power, the exponents. Just ordinary fractions, neat fractions. Subscripts. It's very difficult and very annoying in ordinary fonts to get these things. I should just, as a science writer, these are some of the phrases I came across in the last few months to show you what ordinary newspapers or Scientific American has as science. So subscripts and superscripts. Again, superscript. This is environmental science or archaeology. This is from neurobiology, statistics, bicycle racing, and of course ESMC squared. Okay, so this is if you just had these things handy and they were catered for, it would be very easy for anybody, a teacher, educator, whatever, to do some science. So our solution, of course, is to use ATypI. ATypI is a very smart technology, and you can use ATypI to get these things together. The implementation, what we did, we decided to make a stylistic set. A stylistic set 20 could be any set, but 20 is usually not used yet. Because it's very versatile and you can use all kinds of substitutions you want to have. So this is in FontLab what it looks like. You can make a feature SS20. For instance, just to make the multiplication sign, in sums usually the multiplication is in between spaces. So as soon as you see a space, an x, and a space, you substitute the x by multiply. Same goes for a hyphen. So you type when you see a space hyphen space, you make it into a minus. So the upper part is without the stylistic set, and the lower part is with the stylistic set. And you can see this goes well. This goes well too, but we have a problem with the -2. So because it's not surrounded by spaces, you have to rethink again. It's a bit. Many people will have played with assembly language programming in the 80s. This is a bit like assembly language programming. You find one solution, you get a new bug, and you try to find solutions for new things you come across while experimenting. So what you do is you make a new class of digits, and you say, okay, if it's a digit, that should be in a minus as well. All the digits, of course, we have the old style figures too. And this seems to work. Okay, that's great. That's one. Another problem, for instance, is with exponents, with the 3 to the power 5. Scientists usually, in the days when we didn't have nice fonts, used the circumflex to indicate a power. It's almost everybody does that today, and it's built into LaTeX. For instance, if you use LaTeX, you know the circumflex is a power and the underscore is a subscript. So that's what we do. And we do the same for underscores. And again, we have some refinements, you know, to make it very sophisticated, to use the intelligence of OpenType. If the digit, this is for the subscript. If you have a subscript after a digit after subscript, it will be a subscript as well. You know, it's a bit like implementing fractions. So we get this and this. And it all seems to work. Here's another small substitution, which is comes in very handy for chemistry. And as you can see, it is all very transparent, and people who use science writing, who use LaTeX, will do this without even thinking. A new problem is italics. Italics have a special meaning in science. It's not just italics. They have an italic M is different from a Roman and upright M. So these are some kinds of formulas you want to have handy as well. You know, just typing them without thinking. On a semantic note, for typographers, and small caps is just another appearance of an A. It's just a stylistic variation of an A. But like I said, for scientists, there's a difference between a superscript 2 and a 2. You can't just say, okay, well, we'll use it as a 2, because it's a completely different meaning, and a variable for a scientist is not the same as a constant. So the I italic is a variable, and the I as a upright is a constant, so the square root of -1. So you have to think about that as well. So how do we implement the italics? Well, it's very easy. Unicode thought of that in version 3. They made a special plane, a very distant plane, 1D400, to cater for italics and for bold and for Gothics and all kinds of symbols mathematicians have invented to use. For instance, this is the italic plane. It starts with the AD434 and it goes down all the way to Z. The H had already been given away. So what we did, we incorporated the italics into the Roman font. As you can see, this is one of our fonts, and we made all the italics. It's easy just to paste them from your italics. It's just a bit of trouble, and we also made Greek, the italic Greek, because scientists use italic Greek only. They hardly use any Roman Greek, and that's too is supplied by the Unicode code points for that as well. So just to remember them, we put the .it before them, and again in SS20 it's very easy to implement them. What we did, we used a $sign to escape the A, for instance, the capital A. So $A would become an A.it, so an italic A. Again, scientists who use LaTeX know the dollar will be a mathematical equation. And again, we have a kind of a caps lock built in that if the Roman is following an italic, it will be italic as well. So you don't have to use all the $ signs all the time. So now we have very easy. You see the Greek is a backslash, and this is a solution which is very easy to use, and it's very transparent and very. When I do my presentation, I use my own fonts all the time, and it's fun to use in a way. You just type this and you see the lower side coming up. What's the problem? The problem, of course, is this is okay if you have a font using SciType. But what if you send this to a colleague who doesn't have a font using SciType? Then she gets this. This would be okay for a scientist. She can forget the dollar sign, but she knows what's going on. But there's even more of a problem if you're a Unicode enthusiast, and because we insert garbage into the glyph stream, the dollar signs and the circumflex, for instance, we fuddle around a bit. This is what just a square would look like: a dollar, an A, circumflex, and a 2. So in Unicode, this would be, and that's not what we wanted for a search engine. So it's different. What we really want, of course, is an A square, which would be translated to just the italic A, the mathematical italic A, and superscript 2. We can do this, but we can't use OpenType. So we can't use the smartness of OpenType. There are many expander utilities. This is one text expander. You have Keyboard Maestro on the Mac, and there are many on Windows as well. And these can insert Unicode into the glyph stream pure as Unicode. So, here you can use snippets and translate them into Unicode. For instance, an italic G would be just the Unicode over there, 1 whatever. So this is one way to circumvent the problem. But of course, now if the font doesn't have these characters, this is what your colleague would get. You know, the undefined symbol and the rest. So it's even less intelligible. So it's a kind of a trade-off. You know, our SciType is a kind of a hack just to make things easier. But if you really want Unicode, you can't use it. But if you just use it for your own presentations, for your own quick notes or text or whatever, it comes in really handy. And I think it's just a good way to give the user access to all these signs, symbols, all these superscripts and subscripts they use on a daily basis, and which has been more or less, you know, they've been left in the cold by OpenType and by font designers and by typographers. So SciType tries to provide the ease of use with OpenType for science types, and this is what it looks like. This is just the beginning of the whole stylistic set coding. It is a bit like assembly coding, OpenType coding, so you have to go back and forth all the time and see what's going on. So it's open source. We decided to, you know, you can't keep it secret anyway. So it's open source where we from Canada Type would hope people would implement these SciType in other fonts, so they get scientists to easier use all the science formulas and stuff they use so often. So it makes it just a bit easier for scientists to use beautiful type. So I think it's an excellent tool, and you're free to use it and discuss it. It's only version 1.0, so we have a long way to go. And I thank Patrick for helping me out with the many hurdles we came across, and I thank you for listening.
I appreciate you noticing that this is an approach that trades convenience for text accuracy, and I have concerns about that. I will point out that there is an alternate solution, which is probably not as convenient, but would allow you to retain accurate text. Other than the text expander approach that you mentioned, you could deliver alternate keyboard drivers to map to the correct Unicode characters directly, which is something that we do with our symbol fonts, for example. Thank you.
Yes, we've looked at that, at keyboard drivers, but first of all, they're very difficult to program. I mean, OpenType is easy compared to programming keyboard drivers, and you have to do a new keyboard driver every time Apple decides to make 10.8, 10.9, whatever, and you have to do it for Windows, you have to do it for, you have to be backwards compatible. So we think this is convenient not just for the user but also for the programmer, and keyboard drivers are, you know, it's a difficult way to go, but it is in principle possible to do with the keyboard driver. We think Text Expander can take care of a lot. Thank you. No more questions. Okay.